Hello, it's Miss Van Fleet, and today I'm going to be talking about statistics. And statistics is the process of collecting, displaying, and analyzing any set of data. So you can see there's two graphs here. This one has to do with the climate of Corvallis, and this one has to do with the U.S. Immigration history, and we'll talk about those a little bit later. But first of all, we're talking about statistics. There are steps to actually getting that data and what you actually do with it after you get it. So the first thing is you have to figure out what question do you want to ask, and then you have to refine that question. Then we have to collect the data and then do an exploratory analysis of the question. Like, is the data actually appropriate for answering the question that I wanted? And if it's not, do I need to collect new data or ask a different question? Third step is to analyzing the data, and that's assessing the actual results of it. So we got to find the statistics that best describe your results, and that helps lead to the final step, which is how I'm actually going to communicate it. And when I'm using statistics to describe my results, I've got to find the measures of central tendency, or the measures of the center, and we'll talk about that more on a later date, but not today. And then the last step is to interpret that data and communicate the results. Generally, that's going to be best in a graph. And with that graph, we can draw conclusions and make predictions. So, I look at these steps and I think it looks an awful lot like the scientific method. And you do this whenever you are doing stuff in science. So, next, talking a little bit more about stating that question and refining it to be sure you got a good question, because you really can't do much if you don't have a good question. So good questions are the data has to vary. They can't be yes/no questions, and they can't be questions that only have one answer to them. So here are some examples. Why don't you pause the video and figure out whether or not the first question or the second question is better. So they're kind of in pairs. So pause the video, see if you can figure it out. All right, so how old are you in years compared to months? Months is obviously going to be more specific because in the 6th grade, all of you guys are, 11, 12, 13 years old. Not 13, but there. So in months, that's going to be much more specific. How many minutes did you spend for your homework last night is going to be more specific than hours. I'm hoping you guys didn't spend hours last night. And then how many days a week you exercise is more specific than did you exercise? That's a yes/no. Also, do you like to listen to music? That's a yes/no compared to much more specific, and a better statistical question will be how many minutes do you spend listening every day? So when you're figuring out your question can either be categorical or it can be numerical. A categorical question means that the data is going to, the answer to the question is going to be in words. And the numerical data, the answer to the question that you've asked is going to be in numbers. So again, pause the video and see if you can figure out whether each of these following questions are categorical or numerical data. Okay, here we go. Here's the answers. I put C's next to the categorical, and what you can see with the categorical questions is they tend to start with a what or a which. Okay, and the numerical ones all start with how much, how many as their starting point. That's why you're going to answer with a number. And the only tricky one here was I, which says how did. And that's going to be answered with by walking or driving, or so that would be a categorical answer. So whenever we talk about performing different types of experiments and finding answers to questions and stuff, you got to think about bias. So a really good question is not going to have bias, because bias is in any error that's going to contribute to the inaccuracy of your data. And this can happen any way along the actual process of going through this, but we'll start with a question. So take a look at these 3 questions and try to figure out how each of them are biased. Okay, so when I think on the first question, I've got a who bias and a where bias. The restaurant owner is biased because if he's asking you, you're not less likely to say that you didn't have a good experience. And if he's asking me as I leave the restaurant, I want to get out of there and I don't want to insult him. So who and where, I'm not going to get good data on this question here. This next one only gives us 3 choices of ice cream flavors. And I don't know about you, but mine is not one of those 3. And also, they're not equally as interesting. The caramel fudge swirl is much more interesting than just plain old chocolate or vanilla. Now, a hotel that allows people to choose whether or not they can rate their experience or not. Anytime you have surveys that are optional, you're going to get the really, really good, you did a great, great job, or you're going to get, you did a really, really bad job, so you can get the positive and negatives, and hardly anyone that just had a mediocre job is really going to answer your optional survey. So there are more videos that I'd like you to watch that are in Schoolology, which are talking about bias further, but it's on data collection and displaying and communicating the data. So now I'm going to go back to the, so you're asking these questions basically because you want to be able to interpret the data at the end and communicate results of different sorts. So what sort of results are going to be communicated through the following graphs? Again, you can pause it and take a look at it. Some things that I see with this is I see a pattern that it's obviously we have wetter conditions when the temperature is colder, and when the temperature is hotter, I have less rain. Also, you'll notice that the average or the hours of daylight is related directly to, look at this, the maximum temperature. And this one is the average temperature. Okay, so this has lots of really good data on here that I could draw some interesting questions, and overlaying those actually gives us a lot of information to talk about and conclusions we could draw from it. Also, the one here on the right, the immigration history, this has a lot of data as well in it. You can see easily at a glance that the blue here is the people from Europe that actually came. You can see how large the numbers were, especially before about 1930s, and still they did come afterwards, but definitely not as much as they were before. You also can see just a general trend as to when we had more and less people coming. Let's see, after this 1930s, we end up getting a lot more yellow, which is people from South and Central and Canada that are actually immigrating to the US. And you also get people from here, this is Asia compared to before. And then also we get some from Africa that are coming. Look, there's hardly any from Oceania, which we know as Australia, but there are a few. So I hope this was helpful, and continue on with your learning.